Ladies and gents, let's get to the Unit 2 review. All right, so what I did was I listed every single lecture that we've done in Unit 2, and the good news is we were only not together for two of the lectures. Those are the ones I made videos for you for, but the rest of them we were in class together for. Let's go through them quickly. All right, so first, basic probability. Just look that over quickly. Review your two dice chart, but on the two dice chart, there were a couple conditional probabilities. Conditional probabilities are when your denominator is not the grand total. That might be find the probability that you will roll, roll two dice and roll a sum of 7, given that the green die is 3. Whenever you see the words given that or have some given information, your denominator is just out of what's given. We also did conditional probabilities in the multiplication rules. We'll get there in a second. Addition rules. The probability that A or B will occur is the probability of A plus the probability of B minus the probability of A and B. But the key word there is or. And the key buzzwords for addition rules were mutually exclusive or disjoint events. If I draw a card, what's the probability that that card is an ace or red? There are 4 aces in the deck, plus there are 26 red cards in the deck, but then you have to subtract away any red aces you counted, which are 2 of them, the ace of diamonds and the ace of hearts. So review these notes. For everything I'm going over quickly, go back to these notes, look over the examples, but most importantly, look over the homework problems. The multiplication rules. Keywords there were independent events. Is the second trial independent of the first? And that has to do either with replacement or without. Review your homework problems and look at examples that were with replacement and without replacement. If you have, and I'm going to say this as a hint, if there are 2 separate meetings on 2 separate days, those are like independent events because you can choose a representative for the first meeting and then the same representative for the second. But if it's all at the same meeting, one meeting, once you choose a person, they cannot be chosen again. Hint, hint, wink, wink, nudge, nudge. 2 separate events, things could be independent. At the same event, you can't replace things. All right. After multiplication rules, we got into complementary events. What if I say find the probability of having at least one girl out of 4 kids? All right. Well, that's where I wrote to write the number of girls. You could have 0 girls and 4 kids, or 1, or 2, or 3, or 4. Anytime you see the words at least or at most, list all your outcomes. At least one girl would be 1 through 4 girls. That's event A. Having 0 girls would be the complement of A. And so look here on the right. I did 1 minus the probability of getting 0 girls, which means all 4 boys. And there's a 1/2 chance of getting a boy to the 4th power. And I got my answer. Again, all these things are already in your homework. We've gone through them, but review your notes. Everything open notes, open textbook, heck, open review. I mean, you're at home. You have this out in front of you. Probability distributions we went over when we talked about the random variables lecture. Okay, we talked about discrete random variables, which you can count, versus continuous random variables, which are measured. And the thing that makes a probability distribution, which is this right here, I told you many times you're going to have one problem where I ask you to make one, is that all of the probabilities have to add up to 1. If the probabilities don't add up to 1, it's not a probability distribution. Mean variance and expectation. I also promised you that you'll get one problem where you will need to use these formulas, the sum of x times p of x and the sum of x squared times p of x minus mu squared. This is standard deviation right here. If I ask you for variance, you just take away the square root sign, and you'll have to make this chart right here in order to use these formulas. In this lecture, we also went over expected value. All right, if you get an expected value question, guess what? It's the same exact formula as the mean of any probability distribution. They are the same formula. Okay, look through those homework problems and homework answers and your notes. Then we got into what we've been doing for the past 2 weeks now, binomial experiments. We learned many ways to calculate a binomial answer on your calculator. The binomial program for any single binomial probability. The binosum program for multiple. Find the probability of getting between 10 and 15 successes. If there's more than one binomial probability, you use the binosum program. And then, thanks to your friend Mateo, who graduated 2 years ago, you could use the BIDIST program, which gives you the mean and standard deviation of a binomial distribution, which is, by the way, 2 lectures ahead. You could also use page 769 in your book if you'd like. And if P is 1/2, super duper shortcut, Pascal's triangle. Hypergeometric versus, not versus, hypergeometric and multinomial distributions. They are both just like binomial. They're like their cousins. Hypergeometric, though, has no replacement when you do things, but still two options. Multinomial has everything independent, but more than two options. Look at our lecture and look at the lecture examples, but most importantly, the homework examples. Look at those and recognize the word problems. Again, open note tests. So have those notes out in front of you and you can do it. The great thing about being at home, you can fan all your notes out on the floor and just have them there right in front of you and point them out. You're not confined by a desk like you are in class. Mean and standard deviation, the BIDIS program. So if I give you a binomial situation where n equals and p equals something, and I want the mean and standard deviation, you could use these formulas right here, or the BIDIS program. Distribution shapes. This is imperative. Get out that homework packet that we did, worksheet homework packet. Specifically, I know I wrote look at 96 and 100, but look at all of the problems there, including the distributions, normally or bell-shaped, uniformly shaped, skewed right, skewed left, bimodal, multimodal. Look at all the distribution shapes. I put 96 on this sheet right here. What if you have a uniform distribution and the mean is 13,000 and the range is 5,000? So look what I did. I put 13,000 in the middle of this picture and then I split the range in half. Why? Because if the total range is 5,000, that means half of the range is to the right of 13,000 and half to the left. So plus 2,500 and minus 2,500. Oh boy, I hope you can hear my daughter crying upstairs. My wife's taking care of her. All right, and that's how I got the max and the min. So then I said, what's the probability of being between 9,500 and 14,000? 9,500 is an irrelevant number because the minimum is 10,500. So first off, my range is 5,000, so that's my denominator. Mathematically, this might be one of the easiest questions on the test. And then I just find I take 14,000 minus 10,500. And if I do that, I get 3,500. That is actually the answer to number 96C. That's all you have to do. Do not overthink this. Again, you can have this out while you're taking your test. And then we got into normal distributions, how we finished this unit. Standard normal distributions, just get out your Z table and look up your probabilities. Remember, you might have to do nothing at all. Your Z table measures the area from the center out to a certain point. If you want to find an outer area, you subtract from 0.5. If you want to find a particular area, you might have to add or subtract. But look at your homework examples. Non-standard normal distributions are any mu and any standard deviation that you're adding and subtracting, okay? So in order to convert a raw score into a z-score, you use the z-score formula. Gone over that many times. Okay, look at the examples there. Then we took the z-score formula and we flipped it on its head. We solved for x and got this formula right here. Suppose you want to find P10, the 10th percentile, and you have this information. Mu equals 100, sigma equals 15. The first thing I did was I wrote P10 right here on my sheet. Remember, your center is always P50. So P10 has 10% to the left, but most importantly, then that means there's 40% between the center and that line. That's the area you're looking for. I look up this area backwards on my Z table, and I find the closest Z-score to that value, which turns out to be negative 1.28, and then I take this formula and plug it in with the values, and I get my answer of 80.8. Okay, so if I ask you for a measure of position, you find the area from that position to the center, and that's your area, and then you look up that z-score backwards and plug into the formula for x. Last but not least, the lecture that not many people have viewed yet, and good luck to you if you don't, because we'll see how you do. I hope you all view this before you take your test. The normal approximation to the binomial distribution. It is a binomial question, but if n is greater than 400, you can't use binosum. So the mean is n times p. Standard deviation is root NPQ. Just for shortness, I did root NPQ, and I said, what if you want to find the probability of greater than 200 successes? So 200 is right there, but notice I drew my histogram, and I did my 0.5 adjustment. Ladies and gentlemen, that's what you have to do to answer these questions on your test. Write me with any questions. Tomorrow, you're going to get your test, and I'll write you on Classroom what to do.